clipped classroom video for Maths A2, Unit 3, the product and quotient rules. So we're going to look at products of functions. So first of all we'll have a look at some examples, and we have e to the x times x to the power of 5, x to the power of 5 times log of x, natural log of x plus 2 cubed times sine x, and x cubed times 3x minus 4 to the power of 16. And you'll notice in each case there was a times in the middle, so hence their products. And to differentiate them we need a new rule which has the amazing title of the product rule. And this is that if we differentiate, d by dx means differentiate f of x times g of x, then what we get is f of x times g dashed of x plus g of x times f dashed of x. And there is an alternative way of writing it, which is that if we let f of x be called the function u and g of x is called the function v, then we can write d by dx, or differentiate uv, and we will get u dv dx plus v du dx. And some people find that easier to remember because it's a sort of trips off the tongue, as it were. So we'll have a look at an example. For the moment we're going to stick to polynomials, but later on when you start looking at working with trigonometrical, exponential and logarithmic functions with differentiation, then you will use these rules with those functions as well. So what we're going to look at is x cubed times 3x minus 4 to the power of 16. Now, as before, when we were considering the chain rule, it is possible to multiply these out, this sort of expression out, but you can see that it would take ages and be very, very horrible to multiply 3x minus 4 to the power of 16. So having this rule is very handy. Okay, so we say that u is x cubed and v is 3x minus 4 to the power of 16. We need to differentiate them separately, so when we differentiate u, we get du by dx, which is equal to 3x squared, and when we differentiate v, we get dv by dx is, well, we have to differentiate the inner function, the 3x minus 4, which gives us 3. Then we bring the power down, the 16, and take one off the power, and that gives us that 16 times 3x minus 4 to the power of 15. So we have 48 times 3x minus 4 to the power of 15. And notice we've used the chain rule in there. Okay, our rule is that when we differentiate uv, we get u dv dx plus v du dx. So all we have to do is to plug the various things in. So d by dx of our original function, x cubed times 3x minus 4 to the 16, is equal to u, which is x cubed, times dv dx, which is 48 times 3x minus 4 to the 15, plus v du dx, and what I've done there is I've written the v second, 3x minus 4 to the 16, and then the du by dx, which is 3x squared first. And the reason for that is that we want to tidy this up, and it looks easier that way round because we've got our big powers of 3x minus 4 at the end of each term. So if we look at the next step, we can see that both of those terms have an x squared, so we can take that out the front. Both of them have 3x minus 4 to the power of 15. Now the first term, if we take an x squared out of it, it leaves us with x because we started with x cubed, and we also have 48. So in the second bracket that gives us 48x. The second term from our top line, we still have a factor of 3, and we have a factor of 3x minus 4 because we've only got 3x minus 4 to the 15 outside that second bracket, and our term had 3x minus 4 to the 16. So we now notice that in that second bracket we have a factor of 3. So we can take that out, and next we put that at the front and we tidy up that second bracket in the line above. So our 16x plus 3x minus 4 becomes 19x minus 4, and then we have tidied it up as much as we can. So we've found that when we differentiate x cubed times 3x minus 4 to the power of 16, we end up with 3x squared times 19x minus 4 times 3x minus 4 to the power of 15. Wow. Okay, so moving on to quotients of functions. Again, we'll have a look at some examples. And a quotient, of course, means something divided by something. So we have e to the x divided by x to the power of 5. We have x to the power of 5 divided by log x plus 2 cubed divided by sine x, and 3x minus 4 to the power of 16 divided by x cubed. And to differentiate them, we need a new rule called, astonishingly, the quotient rule. Now, alternatively, we can use the product rule combined with the chain rule to differentiate quotients, and sometimes that is easier or nicer, and you can have a look at that if you wish in the video 2.3.6b4, which is the proof of the chain product and quotient rules. But for now, we're going to use the quotient rule. And the quotient rule says that if we differentiate, so d by dx, the quotient f of x divided by g of x, then what we get is f dash of x times g of x, take away g dash of x times f of x, all divided by g of x squared. And similarly to the product rule, if instead we define f of x as the function u and g of x as the function v, then the quotient rule becomes d by dx of u over v is v du dx minus u dv dx divided by v squared, which again, some people find that easier to remember. Although a cautionary note there is it's very easy to get the top terms the wrong way around, in which case the answer would be the negative of what it should be, so do be careful with that. And following the proof of the quotient rule will help you to remember the right way around, so it's very definitely worth looking at the video mentioned on the screen at the moment. Okay, we'll have a look at an example. So again, we're going to stick to polynomials, and you'll work with the other types of functions later. And we're going to look at 3x minus 4 to the power of 16 divided by x cubed. So first of all, we're going to say what our u and v are. So u is going to be the top of the fraction, of course, and v is going to be the bottom, or the x cubed. Now, we've already differentiated these, so we'll just put those in. So we've got du dx is 48 times 3x minus 4 to the 15, and dv by dx is 3x squared. So there is our quotient rule in the u-v form, and as before with the product rule, we just have to substitute in, and so we get d by dx of that quotient is the v, x cubed, times the du by dx, so that's 48 times 3x minus 4 to the 15, take away u, which is 3x minus 4 to the 16, times dv dx, which is 3x squared, and again I've put the nasty bracket at the end so that when we tidy up it's easier. So we take out common factors, and we can see this time, because we already did this, we can see there's a factor of 3 in both of them, there's a factor of x squared in both bits, and there's a factor of 3x minus 4 to the 15 in both bits. What that leaves is, for the first term on the line above, we're left with 16, which is 48 divided by 3, times the x, and the second term we just have a factor of 3x minus 4, which has to be subtracted because it's a subtraction on the line above. And we've also made x cubed squared into x to the power of 6, which is going to make it easier to do the next line of bit of cancelling. And indeed we can cancel the x squared on the top with the x to the power of 6 on the bottom. Also the final bracket, we have 16x take away 3x, which is 13x, and then we have take away minus 4, which gives us plus 4. So our final answer is 3 times 3x minus 4 to the power of 15 times 13x plus 4, all divided by x to the power of 4.